Hello, and welcome to our webinar on Device Authority's new IoT security platform. My name's Leanne Gilson, and I will be your moderator. Before we get started, let me first cover a few logistics. We expect the webinar to last approximately 50 minutes. During the webinar, if you have any questions, feel free to submit them using the Questions tab on your GoToWebinar control panel on the right-hand side of the screen. We will be monitoring your questions and will respond to as many of them as we can at the end of today's presentation. Contact details are included in the final slide, so if we're unable to address your question today, or should a question arise after today's session, please do feel free to contact us. A recording of this webinar will be made available later this week on the Device Authority website, and everyone who registered will be emailed the link. Now on to the webinar. It's my pleasure to introduce our speaker today, Talbot Hardy, CTO and co-founder of Device Authority. Talbot has deep experience in the security field and has held executive and senior management positions in product development, marketing, and information technology for startups and publicly held corporations. Prior to founding Device Authority, Talbot was the Chief Development Officer at Network Equipment Technologies and was responsible for redefining the company's vision and product strategy for unified communications, SIP trunking, and enterprise mobility markets. He's also an inventor of several patents related to network communications and security, and on weekends can be found doing burpees, box jumps, and other activities at his local CrossFit gym. I shall now hand over to Talbot.
Thank you, Leanne. That's quite an introduction. Hello, everyone. Thanks for joining me today for the webinar. Today I'm going to provide an introduction to our new KeyScaler IoT Security platform. So before I get started with the product, I wanted to spend a couple of minutes highlighting how we brought the platform together and the partner input that helped us drive our innovation and priorities for the new product. Just as some history, we started back early 2016 as two separate companies, Cryptosoft, which was focused on policy-driven data encryption, and Device Authority, which was focused on device authentication. And we completed our merger in April and set out to tackle the challenge of converging the two separate products from the companies into a single unified IoT security platform. We had a number of options about how we were going to go about that and put the products together, but we chose to take a step back and take the high road for kind of the long-range vision of what we wanted to do together as we joined and merged the companies. And we laid out an entirely new architecture that brought it all together into a single code base with a foundation that we could easily build upon going forward. We've named the product KeyScaler because it's all about the keys, generating them, provisioning them, and managing them at IoT scale. So we got a lot of fantastic input from partners like Intel, DigiCert, Symantec, who are all well-versed in security, and others like Machine Shop and NVMe who have helped us focus on the challenges of scaling IoT solutions. We designed KeyScaler to address the need for IoT security automation. And let's take a look at why that automation story is such an important mission for us. If you look at the Gartner Predictions here, it paints a clear picture of what the proliferation of IoT devices will do to the information technology industry over the next few years. The first point that Gartner makes here is that device manufacturers are not in a position to solve the IoT security problems alone. They are going to have their own challenges about the security enablement that they create for those devices. But, you know, as evidence of this, we can look to the recent DDoS attacks involving, you know, 1 million plus IoT video cameras, and just point to the bottom line here that manufacturer-controlled security posture is simply not going to be the answer for IoT security, especially when we're talking about medical devices and healthcare, whether we're talking industrial or SCADA implementations. There's going to be a strong need for independent, owner-controlled security posture. And ultimately, we'll see a huge budget impact on organizations as they work to secure their IoT implementations. And this is the problem the Device Authority is set out to address, to enable organizations to establish and manage their security postures at IoT scale. So if we look at the vision for the product, it comes down to these kind of 4 foundational elements. The first is really industry-leading IoT security automation. That's automated device provisioning to support large-scale headless onboarding of IoT devices while enabling that owner-controlled security posture that I talked about. And then also credential management with PKI orchestration capability that brings intelligent authentication and authorization to the certificate revocation and renewal process. And then also we're focused on that industry standards adoption, and we want to make sure that we're keeping track of and embracing the standards that are coming out for IoT security and communications protocols. There's some great work going on out there to address these, and one of them we can point to is the recent IIC security framework. It's a pretty lengthy document. It goes into some really good detail, and the fundamentals there for that security framework are elements that we're embracing in our own product. So let's talk about how KeyScaler delivers IoT security enablement and automation. First, we look at that combination as the key things that we can offer, the key value proposition that we can offer our customers who are putting up their IoT and implementing their IoT applications. Ultimately, what KeyScaler does is provide rapid enablement and automation of IoT security that allows organizations to focus on the business problems that they are looking to solve with IoT. KeyScaler can save months of development time and provide operational efficiencies that can result in a very quick, hard ROI when it comes to security deployment and management. As I mentioned, we started with a clean sheet of paper when it came to the architecture of the KeyScaler platform. The entire system is built on a service-oriented architecture for scalability and extensive API support for ease of integration and interoperability. We wrapped the system in a service access layer to support agent-based drop-in device provisioning and data security. And we have also added service connector support to integrate into partner IoT platforms and managed services. So these 4 elements are really the core of what we're focusing on. And as we kind of go around the horn here, that automated device provisioning, which is driven by policies that can be preset in the system, and then allow headless onboarding, registration, and provisioning to occur for the devices. And this ultimately allows individual organizations to establish their own owner-controlled security posture and device whitelisting into their applications. From there, we can include credential deployment and management. And that includes the connectors that we've got with companies like DigiCert, where we can orchestrate the delivery of signed CA credentials for managed CA services to the devices. And then we can also use a lot of our patented technology to drive policy-driven encryption. So think about this as going above and beyond just kind of on or off transport security, and allowing you to have end-to-end data security coming from the device through third-party networks and services all the way back to the enterprise application, and not relying on transport security alone to protect that data flow. But the added benefit that you get from that is the intelligence, so that you can do data level, audience level encryption to kind of tailor to the needs of the application and how data gets protected and delivered to specific audiences that are consuming that data. So that's another key element of what we bring in this platform is policies to manage that. And then lastly, in our next upcoming major release, we will be introducing secure OTA updates, actually just secure update delivery to devices, whether that's over the air or over the network, with an encrypted update package delivery that does not expose the binary to the outside world and targets encryption to the specific device that needs to install it, while verifying the source that device is getting it from, and also validating the content that's included in that update package. So what's behind that drives this whole process is some technology that solves a fundamental problem for IoT, and I like to call it the chicken egg problem. So in most cases, the big question about security is how you bootstrap it between the device and the system. And there are a myriad of ways to do that. Some of them are very complex, some of them are very expensive. Most of them today are manufacturer seeded, and that creates a problem in itself, because the owner that ends up taking over the device does not really have control over the keys that are in play for that bootstrapping and security. What Device Authority does to solve this problem is it uses our dynamic device key generation as a way to bootstrap that process for registering devices and authenticating those devices as they're being provisioned with credentials and keys. And also it can be used to protect the initial data flows from the device to the system or service without preceding keys. So we've got device authentication keys that are dynamically generated. They're unique to each device, and they're unique for every single authentication session. From that, we can use our device-derived crypto to generate crypto keys on the fly for each session. And those crypto keys are not stored on the devices or the server, so they get generated by the device for that session, and they can be regenerated and delivered to authorized key requesters that are also authenticated on the other side. So that kind of turns the whole data crypto payload that's flowing back between devices and services into individual snowflakes for encryption, if you will. And we've got an extensive patent portfolio that supports what we're doing with that technology, and it is a great enabler for starting the kickoff of how we onboard devices. So I've got a couple of different examples here, and I've got a little pre-recorded demo that we're going to go through in a minute. The first thing I want to talk about is this policy-driven encryption and how we kind of add intelligence to that crypto as opposed to simply relying on a TLS session and transport security to protect the data flows between devices and the system. So we've got that device-derived end-to-end crypto, very, very important and it's also enables very high efficiency encryption. So a lot of stuff today with these low power devices, we need to see encryption that is, it makes it low compute capability supportable. And a lot of companies are, we're looking at moving to elliptical and things like that. If you look at our dynamic device crypto, we can actually utilize AES encryption, which is much more efficient than any asymmetrical encryption. And we can, but we do that without relying on static keys. So that's a major benefit in what we can do there. But as you know, AES 256 is a standard, and it's pretty high strength solution. So we can use that, and of course we can support PKI based security as well. What we can add to that in terms of intelligence are the device specific security policies. So this is the ability within the system to bring policy and apply it to specific devices or specific groups of devices at scale, so that that policy enforcement gets pushed down, and it can be used to really kind of direct how the data encryption happens between the device and the application that it's talking to. So that's a big benefit there, and ultimately what this does is it puts the customer or the device owner or the service owner in control of their security posture, independent of what was originally seeded into the device. And with our system, we support multi-tenancy, so this is something that can be hosted in a cloud for a service provider, and allows individual policy controls for each individual tenant that lives within that system. So to see this in action, just to give you an example, here's just a simple healthcare example. On the device side of the equation, on your left, you've got a device. It's kicking out some patient data, and it's spitting that across an MQTT broker network. Device authority at the top there, the KeyScaler system has provisioned that device agent with a specific policy on how to handle that encryption. The application itself sitting on that device doesn't need to do anything with that. That agent is capturing those payloads, it's applying the encryption policy to them, and it's doing that in an audience specific way. So that data, as it flows into ThingWorx in this case, because we provide an extension for the ThingWorx IoT platform, can cryptographically deliver that to the ThingWorx and keep it encrypted at rest within the ThingWorx platform. And then, depending on the audience that goes into the ThingWorx application to retrieve that data, it can apply different decryption policies to show only the data elements that are relevant for that particular user. And in this case, we're showing one view, what the clinician would see, and another view of what a technician for the device itself may see. And that kind of adds and highlights the intelligence layer that we can add to that. You can't really do that effectively with transport level security. It just doesn't have the intelligence to do that. It's kind of an all or nothing shot. So let's move to the product demonstration. What I'm going to show here is something that we showed last week in a different webinar that we did with DigiCert, our partner, and highlighting their Cert Central service. This diagram shows how Device Authority and DigiCert work together to deliver PKI security automation at IoT scale. So this is high scale provisioning and certificate deployment. The Cert Central Managed CA service is going to provide the trustworthy PKI credentials for IoT devices, and Device Authority's KeyScaler platform is going to interoperate with Cert Central to provide the policy-driven security and orchestration for controlling device registration and the PKI credential provisioning. So first, the device is registered into the KeyScaler system, which generates PKI credentials that will be assigned and provision to the device. Very shortly, we will also be able to take the flow where secure elements and TPMs are triggering their own private key generation and facilitating the signing of those credentials and certificates through a managed CA process for verification. And then next, the certificate is going to be signed by Cert Central through that service API that they offer and then securely delivered to the device according to the KeyScaler provisioning policy. So let's take a look at the process in action through a pre-recorded demonstration. Here's what you're going to see in the demo. You're going to see the security automation setup. I want to stress that this is the beginning of this demo is a one-time setup that you put in the system, and you establish the service connector. I'll just show you where that's hooked up to talk to the Cert Central service, the common name template to dictate how those credentials are going to be created. There's a certificate provisioning policy, and then there's an overall device group. And so we're going to set all those up, or actually I'm just going to walk you through and show you how they're already set up. And then we're going to set up a registration control record. We're going to allow an automated device registration with an automated group assignment and an automated CA signed certificate provisioning to the device. In this case, we're going to be using an Advantech IoT gateway. So here we go. This is pre-recorded, and I'll just highlight as we walk through here. This is our control panel. We're going to drop in and look at the connector. We're going to look at the DigiCert connector there. We've blanked out the API key for security reasons since it's our own account. And then we're going to take a look at the CN name template, the common name template, and you can see here we're going to use MAC address. We also have the ability to do automated naming, so we can do provisioning, basically pre-generation of certs. Here you're looking at the provisioning policy itself. And you can see here we've got a target and a method for how we're going to secure the certificate, and also the group, the device group that it belongs to, that we want assigned to it when it comes in. And then we'll take a look at the Advantech Gateways group. We can see that it's got the policy assigned to it, and it's got no members associated with it. So the demo is all about getting its first member in there. For high-scale automation, we can do bulk provisioning, and here we're just going to do a quick single provision. In this case, we get to specify what restrictions we want to place on the device that's coming in to the system to be registered, and what groups and authorizations we want to assign to it when it comes in. And then we're going to show that as a pending registration. And then we're going to go over to the device, and we're going to kick off a process that's going to have it phone home, log in, consume that registration record, and then get those policies applied to it and the certificate provisioned. So we'll fire off that process, and we'll tail the log so that you can see what's going on the device. And you can see that's very quick registration. We'll bounce over to the system. We'll see that that registration record was consumed. We'll see that the device now belongs to the group. And we can bounce back over and see that the certificate was processed with the full chain of signatures all the way through to the root CA, which is DigiCert in this case. All right, so that's the demonstration. There's a lot more to the product that we can do to support those other elements that I went on to, but for the sake of time and the ability to have some time to answer questions, we're going to leave it there and open it up for any Q&A that we have.
Okay, thanks, Talbot. So we do have a question. The first one is, how do you make sure that the device is using the correct certificate?
So that's a good question. So that gets into the area that I talked about where we can actually bind device identity to the credentials that we assign to the device. So rather than just assuming device identity from those PKI credentials, we are able to create a linkage between the credentials that are assigned to the device or the keys that belong to the device and the device identity itself. And that means that we can also enforce that in terms of authentication and authorization to ensure that any potential stolen credentials are not used from unauthorized devices.
Okay, so there's a bunch of questions coming in. The next one is, can you explain how KeyScaler addresses the needs for new lightweight crypto algorithms that might be required?
Yeah, so we don't use our own crypto algorithms. They're all industry standard, and we have implemented those as individual modules and replaceable components within our system. So as those standards evolve, we will enable options for customers to utilize the algorithms that are appropriate for their application. So if they've got heavier kind of gateway-oriented applications, they can use, you know, anything from an RSA to an elliptical, and then, as I mentioned, we can always get down to kind of very efficient symmetrical encryption where we've got the need to support low-power devices. And as those standards evolve, one of our key missions for this product is to adopt those standards and add them as capabilities into the platform.
Okay, so next question. Which platforms can use this approach? Except we showed Linux. What other platforms can be used?
Yeah, so we support all kinds of different Linux devices today. We also support, we've got projects that involve MCUs and embedded devices with no operating system basically, or micro Linux kernels. We've also done Windows, Android. We've even done iOS devices, so and multiple different flavors of Linux as well. So that device support is there depending on the platforms. There are some things that we're looking at down the road which deal with RTOS environments, so where we've got that the need for real time. But we're not quite there yet. We haven't done that yet, but that's something that we've got on our roadmap.
Okay, next question. Does the platform performance depend on the number of connected devices?
It can. The authentication process is, as you saw, it's a sub-second process. So in today, it is a connection-driven. I guess it's a connection-driven process, but we scale laterally with those engines. So the engines can scale laterally to support a very large number of sessions, and again, those individual authentication sessions are sub-second in nature. We do have our eyes on how we can do fan-out in that process. And that's something down the road that we will be pursuing when we get into very high scale, and again, that real-time environment support that that may be needed down the road.
All right, so this is a combination of a couple of questions around the same topic. Can you talk a little bit more about how you work with small devices like sensors or small compute devices?
Yeah, so there's different classes of those, obviously. When we talk about small, obviously there's a whole bunch of brownfield devices that have been deployed already that really don't have a lot of capability. I mean, they don't even have the ability to really identify themselves, let alone go through some security, authentication process, etc. So if we think about what we can do, it kind of goes in steps. For those devices, you really can't do much of anything, and I think the key answer for individuals looking at what to do in those environments, the reality will be that there will be a security vulnerability and an exposure over time if that stuff becomes, that machine-to-machine world becomes, an IoT world. So there's some security sensitivity there. I would basically say that if the application is a security sensitive application, there needs to be a plan to evolve those devices into something that has the ability and capacity to be able to enforce security. And there are some great new platforms coming out. I mean, Intel's got some Quark stuff. Samsung's got their Arctic platform. There's some great low-powered device platforms that are coming out that have tons of capability for us to operate within to do what we need to do. And we also have, in terms of the key provisioning and so forth, we have approaches that can be both, a full client-side agent-oriented approach, which is a drop-in approach, or we can do things that are agentless, where we are remotely handling the key provisioning through some very tight kind of timer-based code and stuff like that. So we've got some versatility in how we can implement our security, and that will be, that there's a lot of devices out there that, in some flavor or another can utilize our technology. There's some devices that simply can't because they're just kind of brownfield sensor devices.
Okay, there seems to be a bunch of questions about the crypto capabilities. Here's one. Do you support other types of credentials such as OAuth 2, OpenID, Connect, or JSON Web Tokens?
We do JSON Web Tokens. OAuth is something that we've got on our roadmap, and that's really kind of more of a drive towards the back-end side of how we can apply device authentication as a factor of authentication for the access to the back-end access to the system. So, and when we do that, obviously we can kill it on the other side as well. But yeah, that's something that we're looking at. We don't have that yet today in the product.
Okay, here's a question about embedded platforms. How does it work on embedded platforms? Does it wrap somehow the original software?
So we provide it in a couple of different forms. So one form is a library that can be added into that embedded application to perform the functions that we perform. And that's a common integration strategy. So if you wanted a very tight coupling and to leverage our IoT security capabilities within the application, you can just introduce that library into your application. Secondly, we provide an agent base. So this is a standalone agent. It can be dropped in. It kind of acts as a proxy, if you will, for the application. And then when the application goes to communicate, that agent will will take that payload and do what it needs to do to authenticate the device and provide the encryption.
Next question is kind of a business question. It says, does this scheme assume that device authority has a contract with the device manufacturer and the final user?
It does not necessarily have to have a contract with the device manufacturer. There are some that we're working closely for that tight integration, and that's just basically kind of the same story that you see with everyone else that's involved in the IoT ecosystem. So that kind of collaboration and interoperability is a fundamental necessity to making this all work, and we're part of that. But there are many devices which this can be post-manufacturing installed and implemented for the owner of the devices and applications.
All right. Back down to encryption. Can you please describe the specific encryption you use?
So the encryption that we use today is a combination of asymmetrical and symmetrical encryption for the authentication process and the device-derived crypto. So for efficiency's sake, the payload itself is typically done with symmetrical encryption, i.e. AES 256. The ID keys that we use as we pass them back to kind of encrypt the challenge response process that we do, or the initial key associated with unwrapping the challenge and response, is a PKI key, which is an RSA 1024 key today. And because we use the combination of that, it's much more efficient than wrapping the entire thing even in an elliptical encryption.
So somebody asked if you could address the footprint size, and I assume they mean on the gateway or IoT device.
Yeah, so full-blown agents that are running on like an IoT gateway can be, let's just call it sub 10 meg with everything in it and running. It slims down considerably for libraries on those large devices, can be down to a meg. It can be up to 3 if we've got to bring in our own open SSL stack to support the encryption and there's no hardware encryption on board to leverage. We can go further down from that for MCUs and embedded devices where, as I mentioned, we've got a much tighter code there. We're talking about kilobytes as opposed to megabytes there to support the authentication and key provisioning process.
So question here, what type of cipher do you use, block or stream?
Block or stream cipher? There's a question that I don't know the answer to off the top of my head. I'm going to have to, let's take that one and find out who sent it and we'll send it back.
Okay.
Sorry about that.
No problem. Are your algorithms allowed in the U.S.?
Yes, absolutely. And the module that we use is a FIPS compliant module, FIPS 140-2 compliant module. Yep.
Actually, the person who asked the block or stream question said, from your description, you're using block ciphers, AES, RSA, not stream. So thank you for answering our question.
Thank you for answering the question. Great.
All right. Any other questions? Oh, okay, there is one more. It says, I'm sorry if I missed this. How do you discover devices in order to provision and secure them? For instance, if you're not aware of the device, how can it authenticate and start the process?
Great question. And you have to realize what we're focused on predominantly here is industrial and healthcare related devices. bringing those in the transportation as well. But in those where we're trying to deploy devices, we can, in terms of consumer, where you just have unknown devices coming into a service, you're going to have a provisioning policy that creates some sort of an activation code or some other method to kind of bootstrap that process, and we can support that through activation codes and OTPs, and that typically involves some consumer on the other end doing something to make the connection between the device identity and the service or their account. But in the case that I showed you in the demonstration, what we showed is headless registration. So how that can happen, obviously if you have a pre-seeded element that you're dropping into the device before it's deployed, and this is kind of where manufacturer bootstrap comes in, then you can leverage that in the process. But if you have a serial ID number or something else that you can, some serialized component that you can leverage in that process, then you can create restrictions around how that device and when that device gets to come in and register into the system. And so there are a variety of different provisioning models that we can support, and you kind of have to look at the details of what that process flow looks like for onboarding the devices.
All right, another question just came in. Has the latest release been tested on a live IT system in an industrial or healthcare setting?
It is under deployment right now in several different environments. So this just came out, I think it was September 19th when we announced GA. So it's early days. The precursor to the combined platform has been running in production for customers for several years now. So this is not a new product. In fact, it's actually our quote-unquote 5.0 release. So it's a very mature product. It's been pen tested over the years. It's been deployed in numerous environments, including law enforcement and industrial environments. So we're leveraging all of that and bringing that together in the combined platform. But the platform itself, this 5.0 release, just came out in September.
Next question. How do you protect the delivery process from device spoofing or cloning?
Yeah, so that also gets into that dynamic key generation process. So part of that process, which is our, again, part of the patent portfolio that we hold, includes a noncing capability, and that noncing capability ensures that a static spoofing or cloning of the device is not going to survive and is detectable. And when you have that, then we can enforce a quarantine of that device if we see another device coming in with the same identity that can't keep up with that noncing.
Okay, it sounds like we have some real security aficionados here. Question, can you elaborate on the RSA versus ECC? I'm guessing that's elliptical curve. I didn't get the advantages of RSA over ECC, which diminish as key sizes grow.
Yeah, I think that, just when we started this, we started out with RSA. From an efficiency standpoint, ECC, is going to be much more efficient. The key sizes are going to be smaller, and so it's going to consume less power and kind of compute capability on the devices. So that's the advantage why we're seeing the lean towards ECC. We use RSA very sparingly for basically supporting the payload that we're wrapping in that AES crypto. And AES 256 is going to be, significantly more efficient than either one of those, either RSA or elliptical, when it comes to the encryption of data streams, significant sizes of data payload. So that's kind of where we lean there. I think where we ultimately will get to is that we will support ECC, but continue to support it in the context of the overall crypto framework that we have in place for that challenge and response process. So that will continue to leverage AES symmetrical encryption where we can introduce it.
Okay, so I think that addresses most of the questions. Some of them I didn't ask because they seemed like they'd already been answered, although maybe addressed a question in a slightly different form. So I'd like to wrap this webinar up and let you all go back to your day. First, I want to let everyone know about our next webinar on October 20th, titled Using IoT to Secure Industrial Property, with speakers from Cumulocity and Device Authority. Details and registration for this webinar is available on our website, and we'll be sending out a link along with a link to the recording of this webinar. And Talbot and I would love to thank everyone for their time and interest, especially all the questions. They're great. Helps make this session more informative for everybody. And we really look forward to speaking with you in the near future. And don't hesitate to contact us if you have additional questions.
Great. Thank you very much, everybody.
Thank you.